Ever since the Victorian era, snowflakes have been revered as perfectly symmetrical, six-sided crystals, believed to be as perfect and pure as the heavens from which they descend. But what if this divine image just melted away? It's 1885 in Vermont's wintry terrain. 20-year-old Wilson Bentley is fascinated by snowflakes, so he attaches a camera to his parents' microscope to capture a photo of one. After countless attempts, he finally gets a clear picture. Thousands of pictures later, and Bentley's collection is dominated by what comes to be our iconic view of snowflakes. Each perfectly symmetrical, yet unique. Bentley even coins the phrase, "No two snowflakes are alike." Across the Atlantic, German meteorologist Gustav Hellmann and his associate Richard Neuhaus are photographing snowflakes as well. However, their photos reveal something entirely different. While each snowflake is unique, many are irregularly shaped, imperfect. It's said that Hellmann accused Bentley of altering certain photos. Bentley countered that any alterations were to remove dust particles or debris from the snowflake photo to show the flake as true to nature as possible. It's now present day in the snowy mountains of Utah, an area that thrives on winter tourism. It's here that NSF-funded engineer Cale Fallgotter and atmospheric scientist Tim Garrett have revolutionized the process of capturing photos of snowflakes to better study their fleeting existence. Predicting how winter storms will affect us depends on how we measure what falls out of them, but current methods are imprecise. Fallgotter and Garrett have developed a high-speed camera system specifically designed to provide the clearest pictures ever of free-falling snowflakes. They call their system the Present Weather Imager, the PWI. Composed of a single industrial-grade 1.3 megapixel camera and a built-in computer, the PWI uses an infrared motion sensor to photograph single snowflakes as small as 100 micrometers. A fleeting moment in time exists to gather data on a single snowflake. In the clouds, too soon. On the ground, and it's too late. So the PWI doesn't isolate or disturb the snowflakes. It waits for the perfect time, photographing them as they fall to the ground, mid-air, unaltered, providing data on a snowflake's size, shape, orientation, and even the speed at which it falls. And if researchers understand all of this, they can determine exactly what type of snow formed in the clouds above. Snowflakes have brief but complicated lives. They start when a super cold water droplet freezes around a speck of dust. This process alone results in Wilson Bentley's famous six-sided crystal. But it's difficult to discover one of these on the ground, because as a snowflake falls, it collides and freezes with other water droplets, a process known as riming, resulting in a little ice pellet called a graupel, the hard-packing snow. If a snowflake manages to dodge these water droplets, it will likely later collide with other snowflakes to form something entirely different, an aggregate, the light fluffy snow. So the PWI photographs falling precipitation and then classifies every single photo. Aggregate, graupel, sleet, ice, rain. Each type of precipitation affects road conditions differently. Projecting these, especially around the freezing point, is a current problem. But with the PWI's data, local transportation departments could issue better weather warnings, with the potential to save lives. The PWI also captures nature in its purest form. Common among snowflake photographers, Bentley hand-selected the most attractive snowflakes to photograph and rejected those less photogenic. What Bentley and many others did was spark the public's fascination and curiosity about snowflakes, leading to the PWI's modern-day answer to how to capture a snowflake.